Hello, my wonderful students. This is Foldable number 6. This is section 2.4, transformations. Oh, supposed to be a little dash there. And these are dilations. And this is the f of x is equal to the square root of x. So we're going to get to our first one. If you notice, the parent function is already drawn for us because we already went over it. So I'm just gonna, right there is good. I think so anyways. All right, so our first one here is a vertical stretch. So we're gonna go ahead and stretch the graph. So let's see how this one looks here. So we have our original function went to here. Now we're multiplying our function by 2. So 0 times 2 is still 0. 1 times 2, 2 times 1 is 2. So at 1, it's gonna be 2. Then we went to 4, so at 4, because 2 times 2 is 4, so at 4, it's going to go up to here to 4. And at 9, which is, perfect, 9, it's going to go to 6, which is above our graph, but we're just going to put it right at the dotted line, just to show you guys. And we can see here, boom. And a lot of you thinking like, oh, mister, it looks like you squished it this way. But we're not thinking of in terms of here. Remember, whenever you're doing a vertical stretch, we're going to be pulling it apart this way. So we actually did stretches, but it just doesn't look like it because there's nothing down here and there's nothing on this side. But if we pick this up here and we kind of pulled it up to stretch it, that's how it would look here. All right. So the second part here is a vertical compression. And another fact though, remember I told you whenever you multiply a number that's bigger than 1, it's also going to be a stretch, and vice versa whenever you multiply by a number that's between -1 and 1. So usually if it's positive, it's between 0 and 1, or if it's negative, between 0 and -1, it's going to be a vertical compression. Okay, so this here, so same thing, we're doing multiplying the function by 1/2. So 0 times 1/2 is still going to be 0, which is there. Now we have 1, and we have 1/2. 1/2 times 1 is 1/2. So at 1, we're actually going to get 1/2, which is about right there. At 2, at 4, we got 2. And 1/2 times 2 is 1. So at 4, we're going to be at 1. And at 9, which is all the way out here, we got 3. But half of 9 is 1.5, or 1 and 1/2. So at 9, we're going to be at 1 and 1/2. So when we do draw this one here, we do see that this is kind of a compressed. We kind of squished it down, and we brought the original parent function here to here.